We're now going to talk about compound inequalities. There are two types of compound inequalities. We have inequalities which are two inequalities, x less than 3, x greater than 0, combined with either the word and, or on the other side of the page with the word or. So a problem will look something like this. I've added these extra lines up above it to help us think, but this is what the actual problem will look like. So statements joined by an and are a conjunction. That sounds like an English word, which is a set of numbers common to both or the intersection of the sets. So an intersection means an overlapping part of it. So we're going to look then for the solution to this inequality here. So I'm going to take the x less than 3 here, and I'm going to take a look at the numbers that are in this set. So x less than 3 actually represents all of these numbers here, and I'm going to draw the blue line there that represents it. So every number covered by this blue line are in this set of numbers less than 3. Then I'm going to go to the second part of my inequality, this part here, and I'm going to take a look at it. X is greater than 0, so that'll be an open dot there, and it's greater than, so it's going to go to the right. Now what I'm interested in is I'm interested in the numbers that are in both sets. So you can kind of see the number line kind of gets separated here into maybe 3 sections. I'm just going to kind of put dotted lines there to show that. Notice starting here at 0, everything on the left side of 0, it's in the top set but not the second set. So not in both. The ones in between 0 and 3, they're in the top set. There's numbers, these numbers are in the first inequality, and these are also, same numbers are in the second inequality. So this group here, not the 0 itself, it's not in both of them, and not the 3 itself, it's not in both of them, but the numbers in between are, this is an open dot there, these numbers in between are, and then when I go to the third section to the right of 3, these numbers are only in the second inequality. So my solution then is this section right here, which is written as, I'm going to say that my x's, and I'm going to go this way, so 0 is smaller than the x's, and x is smaller than the 3. So this is my solution to that problem. All right, so let's look at another one. X is greater than or equal to -4. So I'm going to color in my dot here on -4 and then shade to the right. X is less than or equal to 2. So again, shade in my dot, this time to the left. And again, it has this word and. So I want to know what's in the intersection. So I want to consider the 2. I'm going to kind of look at my 2 ends here. And I see that again, that my numbers that are in between -4. -4 is actually in both of them. You can see this both shaded, so this is going to be a shaded dot. My 2 is in both of them, so that's a shaded dot. And everything in between, again, is in both of them. So my answer, which are the x's, -4 is less than the x's, which are these, is less than 2. And that's going to be my solution for that problem. All right, it kind of makes you think that it's always, your inequalities are always going to look like this for these and problems. Let's try a different one. I have x is less than -2, so here's -2, open dot, less than, x is greater than 2, open dot, and again you can see the sections here. The left section is only in one, the middle section has neither one of them, and the right section is only in one. So remember, with an and, it's got to be in both of the 2 inequalities. So this has nothing, and my solution is no solution. There is no number that makes both of those inequalities happy. All right, so then we have x is less than 4 to the left, x is less than 1 to the left, and again, here's my 2 endpoints here and here. All right, so take a look. Which one of these 3 sections has both inequalities colored in? Well, just this one to the left. This one this time only has 1, and this has none. So this is my inequality going from here. Okay, so the 1 itself is not in both of them, so it's an open dot. So remember, it's got to be in both. These numbers are in both sets. I didn't do this here, did I, on this one? Fill that in. Oh, there were none. Okay. All right, so this is my answer. Well, this time it's not going to be one of these in-between things. It's going to be just that x, here's my x's, is less than 1, and that's my solution. We'll move on to the ors and do that in the next video.